Welcome to this tutorial on building a real-time object tracking system using Java. In this session, we'll walk you through every step required to create an efficient object tracking application. Before we begin, let's discuss the core concepts of object tracking. Object tracking refers to the process of locating a moving object over a sequence of frames. It is widely used in various applications like video surveillance, autonomous driving, and human-computer interaction. We will use OpenCV for Java, an open-source computer vision library that provides a suite of tools for image processing and video analysis. First, let's set up our environment. You'll need to install Java JDK, OpenCV for Java, and an IDE, like IntelliJ or Eclipse. If you haven't installed OpenCV, head to their official website and download the appropriate version. After downloading OpenCV, you need to link it to your Java project. Make sure to set the library path to the OpenCV native library in your IDE's project settings. Now, let's create a simple Java program to open a video stream. We will read a video file or stream from your webcam. This code initializes the OpenCV library, opens a video capture from the default camera, and displays the video stream in a window. Make sure to handle the necessary exceptions for a production-ready application. Next, let's add object detection to our video stream. We will use background subtraction to help isolate moving objects from the background. OpenCV provides several methods for this, one of them being Emoji2. In this snippet, we create a background subtractor instance and apply it to each frame captured from the video stream. The resultant FG mask will highlight the moving objects in the video. Now that we have foreground masks isolating moving objects, we need to find contours to describe these objects, which we can do using the Find Contours method. The Find Contours method retrieves contours from our foreground mask, which defines the boundaries of moving objects. Next, we will iterate through these contours to track individual objects. Here, we calculate the bounding rectangles for each contour and draw them onto the original video frame. This helps us visualize the detected objects in real time. Let's optimize the object tracking using a Kalman filter, which can predict the future position of the tracked object based on its previous states. In this code, we create a Kalman filter instance and initialize the state and measurement matrices. We'll need to update this filter with the positions of the detected objects. Here, we insert the measured positions of the bounding box into our measurement matrix and predict the next state. This allows us to refine our object's trajectory and improve tracking accuracy. Next, let's handle object tracking continuity by associating the predicted positions with the current contours using a simple distance metric, the Euclidean distance. By comparing the predicted position with the centroid of the contours, we can determine if a detected object is the one we are tracking or if it's a new object. Now let's integrate all of these components into our main loop to create a complete real-time object tracking application. Make sure to handle any exceptions and perform proper resource management. This ensures the application runs smoothly without any memory leaks or crashes. Finally, let's summarize what we've learned. We have developed a real-time object tracking system by capturing video streams, applying background subtraction, using object contours, and predicting movements with a Kalman filter. You can enhance this project further by improving the prediction accuracy of the Kalman filter, optimizing processing speed, or integrating a new tracking algorithm such as CSRT or KCF provided by OpenCV. Thank you for your attention. If you found this tutorial helpful, don't forget to like the video and subscribe for more programming tutorials.